Hi, my name is Muhammad Amirul Hafiz, and I'm from Group 2. And today we will start the engine design presentation. Okay, for my group, we use the car model from Mitsubishi, and the model is Pajero. Okay, and for this type of the model, they are use petrol for the fuel type. Okay, next. For the specification, okay, for the model is bore is 81 mm, and for the stroke is 89 mm, and the number of cylinder is 4 inline, and number of crankshaft rotation is 2 revolution for one complete cycle, and for the torque is 220 Nm or 3500 rpm, and the fuel mass flow rate is 1.75 G per S. That's all.
Hi,
Thank
my
you.
name is Wan Muhammad Muzakir bin Roslan. My ID is MH19022. So, for engine efficiency, I use the formula efficiency equal to 1 minus 1 over V1 over V2 power gamma negative 1. Then, V1 over V2 is equal to R. R is compression ratio. So the formula is 1 minus 1 over compression ratio power gamma minus 1. So for the compression ratio is 10, and at temperature equal to 300 Kelvin, gamma is 1.4. By using this, we get 1 minus 1 over 10 power 0.4. So the engine efficiency is 0.602.
My name is Arya, anak perempuan Put. My student ID MH19019. Today I will continue our presentation with the power torque calculation of this 4G93 engine. For this calculation, we use this formula, which is 5252 multiplied by the power of the engine and divided with the speed of the engine. For the power and speed value, we get from the spec of engine, which is 160 horsepower, and the speed is 5200 rpm. After that, we put in the value of power and speed in the formula, and we get the torque value in the pound-feet, which is 161.6 pound-feet. After that, we convert it into the Newton meter that can get 219.1 Newton meter. That's all for me. Let's continue.
Good day, my name
with
is
my
Wan Abdul Shukur bin Rasif, student ID MH19024. Today I would like to continue BSFC brake specific fuel consumption. Given in the board is bore of our engine 81mm, stroke 89mm, number of cylinder is 4, number of crankshaft rotation is 2 rev for one complete cycle, torque is 222 Nm, LI is 3500 rpm. We assume fuel mass flow rate for our engine is 1.75. For the first calculation of BSFC, is area of piston equals to pi bore power of 2 over 4. So we put the value, we get 5.153 times 10 power of negative 3 and power of 2. For the cylinder capacity equals to stroke times area of piston, we put the value, we get 0.459 power of 10 times 10 power of negative 3 m power of 3. Next, for the mean effective pressure equals to 2 pi times number of crankshaft rotation times torque over number of cylinder times cylinder capacity. So we put the value, we get 15.058 bar. For the engine brake effective power, NE times pi per 3 times torque times 1 per 1000. We put the value, we get 80.634 kilowatt. Lastly, for the BSFC, we fuel mass flow rate, we assume 1.75 over engine brake effective times 3600. We put the value, we get 78.13 G kilowatt hour.
Hello,
Thank
my
you.
name is Husna. So today I will present about the engine analysis. For engine type is dynamic, CR is 13.3, displacement is 1834 cc, K is 1.35, VC is 203.8 cc, bore 8.1 cm, stroke 8.9 cm, R is 26.7 cm, initial pressure stand for 1 atm, A 3, M4, GT we have 40, AFR is 14.7 and CP is 1.07. From the data that we obtain, we can construct three types of graph. The first one is pressure versus current angle. The second graph is pressure versus volume. Then we can see here the shape is kind of similar with graph 1 but slightly different. And the last graph that we can conduct from the data is axis versus angle. So this is the shape of the third graph. So I think that's all from me. Thank you.